Okay, so in this video, we're going to talk about naming and formula writing for compounds, which is all this is pretty much referred to as nomenclature. So let's get started. So again, I'm going to just highlight what a compound is super quickly, just so there's no confusion. So we have ionic in red and covalent in blue. Okay, so remember, ionic bonds are transfer of electrons. And then covalent bonds is sharing electrons. So just a quick recap of that. All right, so the first thing I'm going to talk about for nomenclature is ionic. I find that it's easier to explain. Covalent gets a little trickier. It's not really hard or anything. It's just there's a little bit extra you have to do. And then after that, we're going to talk about transition metals. I'm probably going to do this in a series of videos, but we're just going to continue the notes, so it'll just be labeled on the site, easier to read. So for this one, we're probably going to do ionic. All right, so ionic, what does that mean? An ionic bond is obviously transfer of electrons, but it's got a metal and a non-metal. So for instance, say we had table salt. That is an ionic compound. We have sodium plus chloride. So we have our metal and non-metal in ionic form. It's really, really easy. So the metal loses the electron to the chlorine. All right. This is kind of just like a review of last time, but I want to see if, since we know that an ionic bond, has metal, non-metal, covalent is just non-metals. I'm going to give you a chart. I'm not going to go over it or anything right now, but this is more for you to practice, and then we'll go over it in class. So actually, I'm going to have to, because there's people that watch these that are not in my class, but we'll make do. All right. So we have compounds, and then you're just going to put a check mark if you think it's ionic or covalent. And I know this chart is atrocious, but it's all good. Okay, so we have KBr, CH4, RBCl. And these are just compounds I'm making up, so let's do we'll do NH3. These are common enough. All right, so just use your periodic table, pause the video, and check off what you think it is, and I'm going to go over the answers. So, all right, assuming you paused it, that's a metal, that's a metal. That's a non-metal, non-metal. So, ionic, ionic. These are both non-metals, both non-metals. Covalent. It's that easy to kind of tell the difference. I just wanted you to be able to do that before we go to naming. All right. So if you need to copy that, just pause it. But we're going to talk about writing the names and writing ionic compounds. We know how to do the Louis dot structure. I'm going to quickly go over it again, but here's our example for the first one. We have NaBr. Br has 7 valence electrons, Na has 1. So the metal is going to lose its electron to the non-metal, and we're going to have Na plus 1, and then Br. Make sure you draw all the electrons in there. It's important. -1. I've seen variations of this where the charge is in or out. I personally, doesn't bother me either way, as long as you have the correct number of valence electrons. This is how it would be represented on paper, but I'm also fine if, unless I'm specifically asking for this, right here, I'm also fine if you just write it like that. So anyways, now we're going to go over, how do you put these together? How do you name them? It's actually super easy. So say I gave you a name. This is actually sodium bromide. How would you know how many of each element that you have if I just gave you the name? You'd have to use your periodic table. So I want you to copy this chart down. I'm going to make it a little neater than the last one. We're going to have 8 lines total, so make sure you make room for that. And hopefully I did. If not, we're going to be going to the next page. But I think that should be good. So we have our group on the periodic table, and we have like the charge, the apparent charge for the ionic version of the element. 1, 2, 3, 4, 5. Man, I am good. All right, so +1, +2, +3, plus/negative, -3, -2, -1. All right, so we're going to be looking at a few examples of this. I already showed you NaBr, and that's sodium bromide. But it's Na plus, and then plus, I'm hoping I have enough room for all this, and then sodium bromide. And I'm going to go over the rules for naming in a second. I just want you to be familiar with this super quick. So, and how we are, how I'm able to know how many of each one that I have. So, say I gave you sodium oxide. See if you can put together how many sodiums and how many oxygens you have. I'm going to give you a second. Just kind of pause the video and see if you can work it out, and then I'm going to go over it. So I'm not going to open the periodic table right now, but sodium's in group 1. Oxygen is in group 6. Oxygen has -2 charge. So that means that it's going to gain 2 electrons. Sodium only has 1 to give. So that means you're going to need 2 sodiums to balance out the charge of a -2. So that means sodium oxide, not bromide. Sodium oxide is Na2O. So it's 2 Na plus 1 and then plus O -2. And that would be how you would kind of deduce that. So I'm going to give you 2 more and see if you can figure it out. Actually, I'll give you 1 more just because I'm running out of space. The notes will have the other 2, but we'll do AL. Oh, I already gave you an answer. Wow. So we'll do this one. So sodium nitride. All right, so take a second to try and figure that out. I'm going to go over it though. So sodium, again, is group 1. And you don't know this yet, but nitrogen, that's, I guess that was bad on me. I should have done the naming first, but nitrogen is group 5. So it's going to have a -3 charge. You need a +3, you need, 3 electrons to balance that out. So you're going to have Na3N, and this would be 3 Na plus N -3. So that's how you're able to use these kind of charges to balance it out, because overall charge for a compound should equal 0 if it's balanced, unless it's a polyatomic ion, but that's a special case that I'll go over later. All right, so if you need to copy this, pause the video. I'm going to go on to how to name ionic compounds. Okay, so naming ionic compounds is actually very, very, very easy. That's why I wanted to go over it first. So first thing we're going to do is we're going to name the metal substance. So step 1, name the metal on the left. And then this is as it appears on the periodic table. Okay, so step 2, name the nonmetal on the right. With the ending, so ending in IDE. So I'm going to give you a list of some common ones that you're going to see. So these are common. So you'll have nitride, and I'll write the chemical symbol next to it. You'll have oxide, phosphide, chloride. Sorry, I'm not a great speller. Bromide, I'm going to give you about 2 more. Iodide, and sulfide. So these are some of the more common ones in terms of just an ionic compound. Yeah. Now, there are certain things called polyatomic ions, which I have not gone over yet, but they follow the same type of naming structure, but pretty much you're going to name the substance on the left, name the polyatomic ion on the right, with the exception of ammonium, not ammonia. I'm going to go over that a little later, but for right now, this should be good for covering ionic compounds. I'll continue with covalent in the next video, and then I'm going to go over polyatomic ions, and then I will finish up with transition metals. So I will see you in the next video.